Hi. So before we start, anyone here that's not Belgian? One guy, okay. Wow. This session is about entity validation in Drupal 8. Yeah.
You can speak Dutch, or?
Yeah, I don't know. Is there a preference? I mean, I can do it in Dutch too. It's just that if it's being recorded and people want to watch it online later on. Yeah, I'll just do it in English. Doesn't matter. So anyway, so this is about entity validation in Drupal 8. If that's not something you're interested in, you're in the wrong room. So let's get started. I'm kristiaanvandeneynde. I'm a Drupal developer. I work at Decent. That's a Drupal agency in the UK. I live near Antwerp though, because I work remotely. And I'm happily married to my wife, who you can all see in this picture, and I'm a highly sensitive person. It's sort of an affliction that makes your senses overreact to stuff. Sometimes it causes panic attacks, so I always put this in my slides just so that if I do drop down, people don't think I'm having a heart attack. It's probably something else, but do check my pulse, please, if it happens. So, entity validation. What is entity validation? Well, essentially, it's what you need in order to prevent this. I mean, I think you all know this error message. It happens a lot in Drupal 7. Anything that uses the entity API, if something is wrong, if you're using wrappers and you try to access data, you get this. You get an exception, which is good, but you get them more often than you would want them to happen. So, entity validation is something new in Drupal 8 that will help you prevent this from happening. So what does it do? It basically validates content entities, and this is important. I mentioned content entities. In reality, it's fieldable entities, but that is like 99.9% of the time content entities. So it validates those on multiple levels. You'll see what those levels are in a few moments. When it validates them, it returns a list of violations. That is, if it fails, you get a list of violations. If it succeeds, then you just get an empty list. So you always get that list of violations, even if it's empty. It happens automatically in entity form validations. So everything I'm going to show you today is something you should do when you are working with entities outside of the default entity form. Otherwise, Drupal already invokes that API itself. So it's actually not part of the form system. Unlike in Drupal 7, where entities were only validated when you submitted the form, this is actually completely outside of the form system. It's just being used inside the default content entity form. And it guarantees the data integrity of your entities. Well, if your validation is correct, that is. So if you try to save an entity and you first invoke the entity validation API, then you are guaranteed to have a valid entity. So all of your code that relies on specific fields having values, or that relies on a combination of fields, for instance, someone clicked the checkbox says other, that they provide some text in the other field, stuff like that, you are guaranteed that all of that is in order. So when do you use it? Because I already told you that it's already being invoked in the form API. So there are special use cases where you want to use this yourself. So for instance, when you are allowing people to update or create entities through REST, then they're not going through the content form. If you have custom entity generating code, so if based on a specific event in your website you're generating an entity, you want to call the entity validation API. By the way, this could also be rules. It doesn't have to be code. If you use the rules module and you create and save an entity, you may want to consider somehow creating an action that validates the entity. Same goes for migrations, all different use cases. So whenever you're manipulating an entity outside of the entity form. So how do you invoke this? It's quite simple actually. When you have an entity, you just call validate on it. Or if you want to validate a single field of an entity, you just get that field and then validate it. or if you want to validate a property or a delta of a field, and it goes on and on like that. But it's actually not just calling validate. You need to do something with its return value, because what I already said is that it returns a list of violations. So that's what you need to work with. So how do you work with these violations? If you want to check whether there were any violations, because I already told you that it always returns a list, but it doesn't necessarily contain anything, you can simply call counts on it. So first you grab your violations by validating the entity, and then if the count is higher than 0, you know you have a problem. So you need to read the violations in order to find out what went wrong. It also implements the iterator aggregate, so you can just loop over your violations. So you can just have your count if you want to, but you can also just use a for each to read all of the possible violations. It's completely up to you how you implement this. There are some more funky methods on the violation list, which are actually pretty cool. You have the get entity violations method, which gives you only the violations that happened on the entity level. And you have the get by field, which are violations that only happened for that field. There are plenty more of those cool methods. And if you want to check those out, you can just go to that interface. My slides will be posted online later on, so you can check that during your, you don't need to take notes. So what happens when you loop over those violations and you get a single violation? Well, that's when it gets really handy, because every violation has a human readable error or message that just tells you what went wrong. It could be something simple like the name field is required or whatever, but it could be really complex too. But that violation gives you a message that you can just output. It also has some other methods that could come in handy. So one of them is get property path, which tells you where the violation occurred. More on that later. And also you can get the invalid value. For instance, what was it that they tried to enter in the field that actually made it blow up? Again, there's also more useful methods on an interface which you can find in Symfony, because this is actually a part of Symfony. So I talked about several levels of those violations, so let's see where they come from. So there's actually 4 levels. First of all, you can validate on the entity level. It validates the entity as a whole, but also everything on the lower level, so the fields, the field properties, and whatnot. But you can also validate just a single field or an entry on a field. And this is where I need to pause for a second, because there's a difference between a field on an entity and a field entry. It's a field entry is like a single entry in that field. So if you recall from Drupal 7, if you had a multi-value field or a multi-cardinality field, it would, you know, have the first value in index 0, in delta 1, delta 2. So this is actually the delta. And then you have the property of one of those deltas. So for instance, most of the fields have at least one property called value. You can also validate single properties. So if we try to compare that to a car, for instance, let's say you're trying to build a car, an entity as a car. So you could have a field that has to have all 4 wheels. And then if you want to validate all 4 wheels, that's possible. But if you want to validate a single field, you take the third option. Or if you want to validate, you know, a property of one of those wheels, you take the latter option. In Drupal speak, that's actually, and there's a small lie in this slide, but I'll explain in a second. So it's actually you're validating on the content entity interface, or the fieldable entity interface. You're validating on the field item list interface, on the field item interface, and then type data interface. The only lie in this slide is that all of the above are actually all typed data interface somehow. But you don't need to worry about that, because typed data is a whole different beast, and I'm actually here to explain entity APIs validation and nothing but that. So let's look at the levels in detail just to give some examples. So if you want to validate the entity as a whole, you usually want to validate across multiple fields. So a good example would be that if we had a field for the fuel tank and we had a field for the engine, it wouldn't make sense if you actually selected a fuel tank and then selected an electric engine. That just doesn't make sense. It would also cause your car to blow up, I guess. You have field independent validation. So what if you're trying to validate the entity not based on what was being input but based on other data? a good example here would be, what if someone's trying to save a third car when they're flat broke? You don't really want to allow them to do that. So that doesn't really rely on any fields, but it relies on, you know, the author who's trying to save that car, and then whether they already own different cars. So that's all possible on the entity level. So if you want to validate a field on an entity, so this is like the list of all the entries in that field, you can validate across multiple field entries. So for instance, let's take that wheels field again. If you want to have 2 monster truck wheels in the front and 2 mini bike wheels in the back, you may want to throw a validation error, because that's not going to fly and, well, not going to ride either. So then you have a field entry. So this is a single delta. So again, here you can always validate across the lower levels. So what are the lower levels of a single field entry? Well, the field properties. So for instance, if one of the properties was the rim and the other was the tire, then if you had mismatching sizes, you would probably want to throw an error too. And then last but not least, you can validate the single properties. So for instance, the tire size. Let's say you want to select the tire material and you choose wood, then yeah, that's not going to happen either. So defining your own validation. This is how you actually add whatever I just explained. So if you want to have that custom car validation or whatever, how do you add it? It's actually quite simple. You need 2 classes. That's it. And one is actually very small. So you need a constraint plugin. So it's a plugin because it uses the Drupal 8 plugin system. And you need an actual validator. And the validator can be something custom. It can be reused from the ones that Symfony already provides. You can use one that Core provides, but the only thing you need to keep in mind is that the plugin is actually a Drupal layer on top of it. It makes it discoverable, but the validators can come from anywhere. So I don't know if you have any experience with plugins for Drupal 8. It's actually quite simple. It's just a class with an annotation above it, which is a form of Doxygen comment that tells Drupal what it is. So that makes it discoverable for plugin managers. So every plugin always needs a unique ID within its type. And you usually want to provide a human readable label. And the constraint plugins can also define a type or a list of types to which they apply. Now there's something special going on with that, but more on that later. And you want to place all of your constraint plugins in that path, like in that namespace. So you go to your module, the source folder, and then plugin, validation, and constraint, and then everything under there with an annotation will be discovered by Drupal. There's nothing you need to do to make it discoverable except putting it in that folder with the right annotation. So this is one that I've taken from Core. This is actually all there is to it. This is a constraint plugin that is in Core that validates usernames. So you'll see that it has that unique ID, and it's defining it as a constraint, and it has a label. So the key that I mentioned that was a little bit special, type, is already missing. I'll explain on the next slide. So what else is in this class? Well, just a few messages. And these messages are being used by the validator. So it's possible to have 2 constraints that use the same validator but throw different messages for the same error. So you could have a more user-friendly constraint that has more specific errors. Could be. So if you, for instance, you have this range validator, let's say you don't want to throw an error that says your value needs to be between 0 and 99, but you want to throw an error that says your value needs to be lower than 100, that's possible. You just define your own constraint and then you use the same validator behind the scenes. So what about the type? It was missing, right? I mentioned that you need a type key and it's not here. So what about it? Basically the type key tells you what sort of type data you can apply your constraint to, but it's not being used by Core right now. It's documented and you should specify it, but the only place it's being used right now is in the plugin manager. So you have this plugin manager for all of the constraints, and you can ask it for plugins that apply to a specific type. So for instance, you could ask Core to give you plugins for a field reference, an entity reference field, and you would get all of the corresponding plugins, but that's it. It doesn't really disallow you to put one of those constraints on something totally different that it shouldn't support. So it's not really being used, which is why a lot of the plugin annotations in core just omit it, because it's just info that's currently not doing anything. However, I would recommend that you do specify that type key, because by default, it defaults to an empty array, which means this cannot apply to anything, which is weird. It defaults to a constraint that you just can't use. So, but if you want it to apply to everything, which is kind of a safe option to go with for now, you can specify false if you don't know what it could be used for. If you don't know what other developers will try to apply it to, just specify false. It will apply to everything. If you do know what it should be used for, you can specify more fine-grained types. Like you can specify that it has to be used on entities, and you don't care which entity. You can specify that it has to be used on nodes. So you define entity and then colon node, which is the type data ID of a node entity. If you want to use it on a field item, which is a single entry, you just specify field item, and it can be on any field item. Again, you can specify which field item. Field item lists are currently not supported, it seems. There's no typed data for field item lists, sadly, or not specific IDs, that is. Or any other type data, like strings, integers. Again, what is type data? You don't need to care. It's basically just, if you want to use it, you're probably going to use it on entities, or on the very bottom one, other type data. That's just like raw values, like a string, an integer, whatever. I'm just mentioning it for completeness, so that if you do check out the annotation later on, you don't worry like, what's this type key about? Don't worry, it's currently not really being used. So if you do want to set it, you can set it as a string or as an array. So in core, in some places it's being used. So this means it can apply to entities or entity references. If you only support one type, you can just use a string. You don't need to have those curly braces around it indicating that it's an array. So constraints can also take options. And as the word options imply, it's completely optional. If you want to use options, you simply define them as object properties on the constraint plugin. You can accept as many options as you want. So it can be just one, or it can be an array. And how to pass the options is covered later. But this is what it looks like. So for instance, if your constraint has the option that needs you to specify a type, which is, for instance, being used in entity reference constraints, you can specify what type of entity you want to reference. You just create a variable type. If you don't want people to have to actually mention that they are defining the type, you can also specify the getDefaultOption method, which tells you what your default property is that you want people to assign stuff to, and then they can just pass the option as a string instead of having to say, I'm defining the type. You probably don't need to use that. Most validators don't really take options. If you want to use it, you should probably be fine by just defining some properties. So now comes the funky stuff. It's the validator class, the class that actually validates the whole thing. This is a little bit more complex. So validators, first of all, they get this magic class name. So it's just the name of the class that you used for your constraint plus validator attached to it. If you don't want that, you can use a different name. You just have to implement validated by on the constraint and return a different class name, and then it will do that. Why am I mentioning this? Well, as I said earlier, you can make existing validators more user-friendly. And if you want to reuse those, well, obviously you need to find a way to do that. Well, it's very simple. You just return that class name from validated by, and then core will reuse that validator. So the value it receives, and this is pretty important. So when you try to validate a whole entity, it gives you the actual entity. When you try to validate a single field on an entity, so the field item list, it gives you that field item list. For a field entry, it gives you the field item. And for properties, it gives you the raw value. This is really important. You're going to run into a lot of errors if you try to write a validator and you don't know what value you're expecting. It's kind of dirty that it accepts all of these things in the same parameter, but that's just the way it is. So do know where you're going to have your validators used, which is why it would still be a good idea probably to have your type annotation key properly documented. Or you can check for these interfaces in your validator and then do validation based on that. And that way your validator would just apply to anything. It's completely up to you. I've written one of them for the group module, and it just works on the entity. So if you try to use that validator on anything else, it will blow up in your face, and I won't feel bad about it. It's just because it's supposed to be used on entities. So this is what it looks like, and this is the username constraint validator. So what can we deduct from this picture? Well, first of all, the constraints class was called username constraint, which makes this class automatically named username constraint validator. And then you just need to implement the validate function. And that first parameter there is the one that receives the value. The second parameter is the one that receives the constraint that you defined earlier, the plugin, so you can get the messages from the plugin. So that first variable is named anything really. You'll see it being named items in core, you'll see it being named entity in core. It's sometimes named value. You name it however you want, because it can receive all of those things. In this case, the username constraint is applied to a field item list. So this is receiving a field item list, which is why the validator kind of looks like this. So you can see that a few lines down, it just grabs the first item because, well, usernames aren't usually multi-cardinality, and then it just validates those. You can also see that when something is wrong, it just adds a violation by calling this context add violation. A few words about the context. The context is where the validation is coming from. So if you called validate on an entity, like that very simple slide I showed at the start, then it validates the entity and it validates all the fields below it. The context will always be that entity because that's where you started. Your code called validate on the entity, so the context is the entity. If you called validate on a single field, then the context will be that field. Even if your validation goes further down and goes to a property, the context will be that field. This is so that you can specify where the validation or the violation occurred. You can tell, you know, it was in this field and then go from there, and more on that later too. But it's actually quite simple to use. Most of the time you're just going to call this context add violation, and then you just reference one of the messages that is coming in from your constraint. So we're almost through the technical part. So the property path. So what I mentioned about the context. So how do you specify where the violation occurred? That's the property path. So I'm just mentioning this for completeness because usually you don't need to use this. So it tells you where the error occurred. It defaults to the item being validated. So when I mentioned that if you're validating the entity, the context will be the entity. But then it goes down and it knows where it is. So when it validates a field on that entity, it knows it's in that field. So it will properly report that the violation occurred on that field. But if you want your validators to do some funky stuff, and there are some in core that actually do it, you can be more specific. So entity reference fields do this. They have some magic properties that tell you what the actual entity is, but also the target type and stuff like that. They do this. So you're actually validating an entity reference field at that point, but it wants to be more specific. It wants to tell you that not the whole field is invalid, but for instance, the ID of the entity you're referring to is invalid. So it just makes its property path more specific to tell you, well, the whole field isn't wrong. It's just this one property that you did wrong. So you can do that, but 99% of the times you're not going to do that. It just suffices to call this context add violation. That's it. So if you want to see how that works, if you ever have code that needs to be more specific than the actual context you're currently working on, you can check an example in the valid reference constraint validator. That's one of those classes that does that. So examples, because what does a property path look like, right? So if you're validating an entity and something goes wrong in the value property of the first delta of field foo, then the full property path will be field foo 0 value. So it really tells you where it went wrong. Same goes for if the whole delta was wrong, then yeah, well, field bar 2 could be where it went wrong. And this is where you'll see the difference. So this is when invoking validate on an entity. But as soon as you invoke validate on a field, like one level lower than the top level, then you'll notice that the field name vanishes from the property path, because that's that context that I mentioned. So it already knows that it's in field foo, for instance, so it just tells you that the third delta's property bar was wrong at that point, because that's all you expect. I mean, your code is validating a field. You already know what field it is, so it would just be ridiculous to get that value from the violation, so you don't need that, so it's stripped. And when you're validating a field entry, well, you just get the property name, if you then want to get the property path. So now is the really interesting part. So how do we really use this? So we've seen what they are and how you can create them. So how do we use these? It's actually quite simple. If you are creating your own entity type and you have a validator or a constraint that can work on the entity level, all you need to do is put it in your entity types annotation. You just put in the ID or the name of the validator, and then you specify the options. This one doesn't have any options, so it's just an empty array, but you can add your options in there. You could also just enter a single string if that's your default option, or you can be more specific and actually, you know, tell Drupal that for this property I want this, for this option I want this. It's however you implement it. Obviously, you're not always defining your own entity types. Sometimes you want to change an existing entity type. For instance, you have a specific use case for validating nodes on your site, so you want to add a validator to the node entity type. But you didn't create that, so you can't really control the annotation. So how do you do it then? Also, quite simple. You just invoke hook entity type alter. And then you get the node entity type from the list of all known entity types, and you just call add constraint. You put in the name of the constraint and the options. So for instance, my constraint would take the option foo, and I want foo to have the value bar. On the field level, it's pretty much the same. So when you add fields to an entity, you have base fields, which used to be properties in Drupal 7. Base field definitions have the add constraint method too. So you can just call that when you're adding fields to your entity type. So this is what it looks like when you have a content entity type and you add fields yourself. Or if you can't control it again, you have two hooks to change them. You can change the properties in base field info alter, or you can change the bundle fields, which are usually configurable fields and other stuff like that in hook entity bundle field info alter. And again, you just grab what you need and you call add constraint. It's that simple. Then we have the field entry level, and this is quite complex. So a single delta in a field entry is actually what makes the field work, because the field you put on an entity is always a list of field entries. So that doesn't really know anything except for the fact that it's a list of, you know, a specific field type. So in core you can define those field types, and those are the single entries. And that's actually the class that handles everything. So you have for instance, for a entity reference field, you have a field type entity reference. For an options list, you have a field type option, stuff like that. These are harder, but you'll hardly ever need to apply validators there. If you want to, you can, again, in the annotation or in hook field info alter. Most of the time, you're just going to apply validators to the entity level or the field item level, the two first ones I showed, the fields item list level, the two first ones I showed. This one you'll hardly ever use unless you're actually writing a module that defines a field type. For instance, the address module defines a field type. It would serve them well if they had constraints on that field type. If you want to change someone else's field type, hook field info alter. Feel free to use it. Please don't break those fields, because that will break a lot of stuff. And then finally, again, the fourth level, the field property level. Quite easy actually, again, when defining your content entity type. The same way like you would add a constraint to the whole field item list, you can also add a constraint to a single property. In this case, value. This is taken from core again, it's just an example. You can add any constraint you want to a property. again, hook entity base field and bundle field info alter if you want to change another entity type's constraints. If you want to, so this is what it looks like if you are defining. So when you are defining your field type, field types have those properties in their class. If you want to add them there, then you have that method property definitions. And that's what it looks like there. Instead of add property constraint, you just call add constraint because you are defining the property already. You don't need to tell a field to go down into its properties. No, this is the actual property you're defining. So you just add the constraints straight away like that. So that was quite technical. So I assume there will be questions. So that's it. But before I go to questions, a really shameless plug about the company I work for, Decent. We're still hiring a team all across Europe. We have a distributed workforce, so you don't need to move to England. We have a mandatory 5-week sabbatical, unlimited training budget. So if that's anything you're interested in, or hanging out with technical people like myself, awesome. Give me a shout. So yeah, any questions? This was all like, whew, right? Yeah.
Are those 5 weeks consecutive?
Yeah. Yeah, that's not really related, but yeah, those 5 weeks are consecutive. They just tell you to fuck off for 5 weeks and you're not even allowed to check your email. So. Anything else? No, really? All right, so my question to the audience, did you actually get any of this or was it just way too technical? It was good?
Yes.
Okay, awesome. So my advice to you would be, use this. Like, if you're defining your entity type, if you're defining a field type, if you are allowing people to create entities through REST, use this, seriously. You're going to love having used it because your site won't blow up at random points because someone entered the wrong data. It's really useful to use. Yeah, there was one other thing, but I can't remember anymore. So that's it, I guess. Anything else? Nope. Yeah, again, yeah, mandatory sponsor slides, by the way. So, yeah, thank you for listening then.